Today we'll discuss about the project related to I2C. Today I will explain you the basic concept to I2C, and tomorrow we'll see about the programming related to I2C. So basically, like I2C is a serial communication protocol, mainly for communication between the different types of peripheral within an IC. Okay. So here, like I2C. So the I2C, if you see the I2C, so what is the full form of I2C? Means inter-integrated circuit. Okay, inter-integrated circuit, and this is developed by Philips Semiconductor during the year 1982. Okay, no license is needed since 2006. Many I2C compatible devices manufacturers they are manufactured, and this is widely used protocol. Okay, mainly like it consists of mainly master. Okay, and next target devices are slave. Okay, so master can be microprocessor or microcontroller or DSP, or it can be FPGA also. Okay, so master and slave can be some peripherals, like, like different types of low end peripherals. Okay, those are slave. Okay, so there are only two lines. One is like SDA, okay, serial data line, and this is bidirectional. This is bidirectional. So bidirectional means master can send the data from the master to slave, or slave can send the data to the master. Okay, this is HDA line. Okay, and next SCL, serial clock line. Okay, SCL is serial clock line means so master only generate the clock and it will send to the slave. Okay, this is the unidirectional. So it is coming from master to slave. Okay, only two line communication is there. Okay, so it will support only two line communication. This is about I2C protocol, and this is operated at different types of modes, like standard mode. So what is the speed is 100 kbps. Okay, what is the speed of the data rate is 100 kilobits per second, and fast mode 400 kilobits per second, and fast mode plus is 1 mbps, and high speed mode is 3.4 mbps, and ultra fast mode means 5 mbps. Okay, like if you compare SPI and I2C, okay, SPI have four lines. Okay, MISO, MOSI, okay, and clock and data, and four lines will be there. So by using this serial peripheral interface, we can send the data with 10 mbps. Okay, but with so compared to SPI, this is slower only. So maximum data rate it can support is 5 mbps. Okay, ultra fast mode. So maximum I2C will support 5 mbps. Okay, so this is I2C communication modes. Suppose if you want to implement this one into standard mode or fast mode, uh, different timing requirements are required. Okay, for this different timing requirements are there required, and high speed mode means it require controller code for high speed transfer. Extra controller code is required for high speed transfer, and ultra fast mode means write only. It will support write only, and it emits some I2C features. Okay, these are the different types of I2C communication. Okay, and coming to the physical layer, so mainly like you have like VDD, okay, 5 volts, okay, and SDA and SCL. Okay, SDA and SCL is connected to pull-up resistors. Okay, RP. This is pull-up resistor. So why it is connected to the pull-up resistor means, suppose any slave is connected. So basically, like suppose like this is master. Let us take this is master. Okay, master, and here you are getting some 5 volts VDD supply voltage through the pull-up resistor. It is directly connected to master. Okay, this is directly connected to master. So when like this is connected with a switch, and through this switch it is connected to slave. Okay, through the switch it is connected to slave. Okay, so when slave is not connected, it will be in which condition? Means open condition. It will be in like open condition. Okay, so there will be a path from the pull-up register to master. There will be a path from pull-up register to master. So when any slave is connected, so what happens? This switch, so whatever this switch is, the switch will be closed. Okay, which will be closed, and master will identify. So there is a path from master to slave. So master will identify that there is a signal transmitted from. That means there is a there is a path from master to slave, and so many masters and slaves can be connected. So how it is identified means there is a slave address. Okay, there will be some each and every slave have different particular address. By using that slave address, it will find out the slave. Okay, so different. Suppose if you consider you have multi-master, you have multi-master and multi-slave. Okay, so if you consider this one, this is a master micro. So I told you, no, master you can use as a microcontroller or microprocessor or DSP processor or FPGA. Okay, which is having high frequency, which is operated at high frequency. We can use as a master. Okay, so microcontroller 2. Okay, and slave can be ADC, DS. These are some low-end peripherals we can connect. Okay, these all are connected like this. Okay, these are connected to two lines. One is a data line, SDA line. This is bidirectional, and SCL line. This is unidirectional. Master will send the clock to the slave, and it is connected to VDD supply voltage through the pull-up resistor. Okay, so that means if you see any two communication lines for the all devices, okay, it will be communicated by only two lines. One is SDA and SCL, serial data line and serial clock line. Okay, and this is bidirectional communication half duplex. Okay, bidirectional communication half duplex means if you consider serial communication protocols, serial communication, there are like three types are there. One is half duplex, and next, sorry, once first one is simplex. Okay, not half duplex, simplex communication. Okay, simplex communication. So simplex communication means what? If you consider the walkie-talkie. Okay, simplest communication, walkie-talkie. So that means simplex. Only like one person is talking. After completing that communication, only other person can talk. Okay, there is nothing but simplex type of communication. Okay, and next half duplex. Half duplex. So half duplex means what? This is the one-way communication. Okay, suppose this is the one type of half duplex communication. So that means you have master, and next you have slave. Okay, so what happens? Master will send the data. Okay, so master will send the data. After sending the data, slave will give an acknowledgement. After that, slave can only send the data. Okay, parallelly it will be not happens. At a time, first master will send the data. After that, slave will send the data. Okay, one way means we can call as unidirectional communication. Okay, one directional communication. So communication can happen in only one direction. Okay, and next, if you consider full duplex communication, uh, full duplex means your mobile phone is there. Okay, so mobile phone is full duplex type of communication. That means, so what happens? So when you are doing calling, parallelly, so both whoever is calling and whoever is received, both can talk simultaneously. Okay, communication happens bidirectional. That is nothing but full duplex communication. So basically, like I2C will support half duplex communication. That is one communication. Okay. And it allows multiple controllers and multiple targets. I told you, no, multi-master and multi-slave. Okay. So it have multi-master and multi-slave. Okay. And it require pull-up resistors on HD and ACL line. Okay. So as I told you, so that means there should be a path from where to where, from VDD to master. And when slave is connected, initially this is open. When slave is connected, this is shorted, and there will be path from this VDD to slave. Okay. So that is that how we are connecting means through the pull-up resistors. Okay. This is about the master and slave configuration. And and next, if you see the physical layer, how it will be there means there is a open drain connection will be there. Open drain connection means inside there will be a NMOS pass transistor. NMOS pass transistor. Okay. So NMOS pass transistor, suppose when VDD equal to VDD is high, so through the pull-up resistor, what happens? So when any device or logic is connected, so what happens? This becomes one. Okay, this becomes one and this becomes on. Okay, so so quickly it will not transmission. So it will transmit like this. It will transmit. Okay. So NMOS turns on when HDA and SCL pulls low. Okay, when HDA and SCL pulls low, NMOS will turns on. Okay. So so quickly it will not transmit from high to low. So there is some so curve type like this. It will transmit from low to high like that. And this is open drain connection. Open drain connection, there is NMOS turns off. Okay, NMOS turns off when HD and SCL is released. Okay, and when HD and SCL is released, what happens? This will be off. This will be off. What happens? So this will go again. This will go to high. As I told you, no, master is always by default it is connected to VDD. No, okay. When SCL and HDL is connected, it is going to logic low, and when it is not connected, it is going to logic high. Okay. This is open drain connection. This is related to open collector and push-pull related. So this is open drain we already seen, open drain output. And push-pull means there are like two CMOS transistors are connected like this. Okay. Uh, so this we are not preferring. Why? Because when we connect together, this cause some bus contentions. Output state is indeterminate. That means output state we can't determine, means we can't get exact output by using push-pull configuration. So that's why we are preferring open drain configuration. Okay. So this is I2C physical layer. So for I2C, there are two cases are there. One is the start case and stop case. Okay. During communication, when you are starting the communication, you need to start with start condition, and next one is stop condition. Okay. What is start condition and stop condition means? Start condition means first whatever the SDA is there, no, SDA will be first SDA will be pulled low in the start condition. Okay, HDA will be pulled low. After that, SCL. Okay, this is HDA. HDA will be pulled low. After that, SCA will be pulled low during start condition. Okay, pulled low. See here. So this is for controller device claim the communication I2C bus for communication for the target device. That means in order to communicate master to the slave, first what you need to do, you need to pull HDA from high to low first. Okay, so from high to low first. After that, you need to pull SCL. After pulling HDA to high to low, again next there will be some delay between HDA and SCL. Okay. After that, you need to pull SCL from high to low. Okay. This is nothing but start condition. Okay. This is nothing but start condition. Coming to the stop condition, after means after controller device completes the communication with the target device with the slave, okay, it releases the I2C bus. Okay, it should release the I2C bus, no? So that is nothing but stop condition. So in the stop condition, what happens? This is HDA and this is SCL. Okay, HDA and SCL. So HDA will pull from low to high first. Okay, sorry. SCL will pull from low to high first. Okay, this is first. First SCL will pull from low to high. After that, SDA will pull uh, from low to high. Okay, So this is nothing but which we call as stop condition. Okay, this is nothing but stop condition. Okay, so this is about stop condition and start condition. Hope you understood. First this one will be pulled from high to low. Next, this one will be pulled from high to low. Okay, so first SDA and next SCL. This is start condition. In the stop condition, first SCL will pull from low to high, and next SDA will pull from low to high. There should be some delay between SCL and SDA. Okay, this is about the start and stop condition. Okay, and uh, so here what happens means SDA is a data line, SCL is a serial clock line. So we know that SDA is a bidirectional, and uh, the a serial clock line is passing from master to slave. Okay, so SDA only transmit when SCL is slow. Okay, so that means here you see. So when SCL is low, okay, SDA will transmit the data. Okay, during this state only, SDA will transmit the data. Okay, so that is the case here. Okay, when SCL is low, so the SDA will transmit the data. Okay, so when SDA is high, then SCL pulse is logic 1. Okay, like this. So this is the timing diagram for I2C protocol. First, what happens? This is the start condition. So start condition. In the start condition, what happens? First, SDA will pull from high to low. Okay, it will pull from high to low. Okay. Next, SCL will pull from high to low. This is the start condition. Okay. So this is nothing but my start condition. After that, there are so many masters and so many slaves are there. So that means there is no address for these different slaves. Means parallelly it will communicate with all the slaves. Okay. So that means how to identify. Suppose you have master. Okay, master and some multiple slaves are there. Okay, multiple slaves are there. So if multiple slaves are not there is a connection from master to slave, okay, through HD and SCL line. Okay, so what happens, so this is slave 1, okay, slave 1, slave 2 and slave 3. So when address is not there for the slave, so and means parallelly it will communicate with the master will communicate with all slaves, and the data will be transmitted to all the slaves. Okay, so how to identify this which so master should communicate with only one slave at a time. It will communicate with one slave. Okay, so how to identify means by using the address. Okay, so this is nothing but it's a 7-bit address. Each and every slave has 7-bit address. Okay, so after start condition, there is address frame. Okay, so there is address frame. So this is A0 to A1. This is nothing but address frame. A0 to A7, A6. A6 the 7-bit address frame, address of slave. Okay, address of slave. Okay, so after identifying the address, okay, suppose this is having first address, address 1, address 2, and address 3. Okay, so here it want to communicate this slave, so this is having address 3 in terms of 7 bits. Okay, after that what happens, uh, so this address also that will be transmitted, that will be identified when the SCL is low only. See here, when the SCL is low only, that will be address will be identified. Okay, and after that there is a read by write bar signal. Read by write bar signal. Read by write bar signal means so this is when read equal to when read by write bar equal to 1, it will, so master can read the data from the slave. Okay, master can read the data from the slave. Okay, read operation is happening. Read from slave to master. Okay, and when read by write bar equal to 0, write operation is happening. Write operation is happening. Okay, from master to slave or slave to master. Okay, that is nothing but read by write bar signal. Okay, read by write bar signal. Okay, after that, what happens? There will be some acknowledgement signal. There is some acknowledgement means after read by write bar signal. So master should wait for the slave whether the slave is ready to accept the data or not. Okay, so how it will the master will identify means so it will give some low acknowledgement signal to the master. Okay, this we call as acknowledgement signal ACK, acknowledgement signal from the slave to master. Okay, after acknowledgement, it's like a handshaking only. We already discussed the handshaking, no? So that means it is giving the acknowledgement that slave is that I'm ready to accept the data. Okay. After receiving this acknowledgement, the master will send the data. So how many bits of data it will send? 8 bits of data it will produce. This is the data produce. 8 bits of data it will send D0 to D7. D0 to D7 it will send. Okay. So this is a basic I2C protocol. After that, after sending the data, there is a stop condition. Stop condition we already discussed. First, what happens? So in the stop condition, we already seen, no? First, SCL will go from low to high, no? SCL will go from low to high. After that, SDA will go. Okay. So this SCL will go from low to high first. After that, SDA will go from low to high. Okay, some mistake is there. First SCL, this SCL is there, no? This will go from low to high. Okay. After that, again SDA. Okay. After SDA will go from low to high. Low to high. Okay. So this is low to high. Okay. So when again it is in high condition means I2C is said to be in ideal state. Both are in high condition. Means I told you, no, master is connected to this VDD with pull-up resistor. No, so always it should be high. Master should be high, and when slave is connected, again it will go through the pull-up resistor. It will go to low. Okay, both SCL and SDA will go to low. Okay, so this is the I2C protocol timing diagram. See here. So that means first this is the start condition. So what is I2C start condition? So comes from the controller and sends SDA low before SCL sent low to claim the bus. Okay, first SDA will go to low. After that SCL master should give the clock, no. So SCL sent low to claim the bus. You need to claim the bus. Okay, this is first start condition. Okay, this is start condition. Okay, after that next address. Okay, so master should identify the slave address. Okay, how it is identifying? It is identifying by the 7-bit I2C address. Okay, this is nothing but address frame, 7-bit I2C address. Okay, so this is second part, identifying the address. Okay, after that next is read by write bar. Read by write bar. Read by write bar means what? This is the direction of communication. Okay, direction of communication. So suppose if it is one, controller wants to read from the target device. As I told you, no. So there is a master and there is a slave. When read by write bar equal to one, so master will read the data from the slave. Master will read the data from the slave. This is first condition. Second condition, when read by write bar equal to 1 or 0, controller wants to write to the target device. So there is a second condition, read by write bar equal to 0. There is a master and next there is a slave. So master can write the data into the slave. Master can write the data into the slave. Okay. So this is the third condition. And fourth condition is, as I told you, no, after read by write bar, so master will wait for the acknowledgement. Okay, So this is the fourth condition, waiting for ACK, waiting for ACK, acknowledgement. Okay, acknowledgement, if you see waiting for ACK, SDA, so whatever the SDA is there, no, that will be pulled down. SDA will be pulled down as a ACK. Okay, ACK, acknowledgement. Okay, and after address byte, the target device ACK's communication. So slave should give the acknowledgement to the master that I am ready to accept or ready to receive the data, or you can read the data from my whatever the data you can read, like that. It should go. Is it ready or not? Through the acknowledgement signal, it should go. Okay. So this is fourth step, and this is fifth step. So at a time you can send, this is serial communication. So serial communication means there are two types of communication. Serial communication means suppose 10110110 is there. Okay, one bit you are sending, one bit you are sending. This is nothing but serial type of communication, like USPI communication, I2C communication, UART, universal asynchronous receiver and transmitter. These are nothing but serial type of communication. Okay, so that means suppose each bit is transmitting at 1 nanoseconds. To send 8 bits of data, it will take 8 nanoseconds. Okay. Next part is parallel type of communication. Parallel type of communication means what? 8 bits of data is there. Okay. Same data is there. Okay. So same data you can send at a time, at one clock cycle, at 1 nanosecond, you can send 8 bits of data. Okay. That is parallel type of communication. Okay. So that means within the board, within an IC, there will be parallel communication, or like if you want to communicate between the two different peripherals, that will be communicated through the serial communication. So this I2C and SPA. Okay, this is onboard communication. So within the board, different peripherals are there. So those peripherals are communicated serially. You need to use I2C bus. Okay, suppose your computer is there. Okay, your computer or a laptop is there. You want to interface some external peripheral like LCD or 7 segment display. So long wire communication, that is you can use RS-232 or UART you can use. Okay, that is long distance communication. This is short distance communication. Hope you understood what type of communications are there. So you are sending 8 bit of data. Okay, you are sending 8 bit of data. After that, again ACK. Okay, after sending, master should give the ACK. So that means to write to the target. ACK comes from the target device. Okay, write to the target means so there is a slave. Slave will give the acknowledgement to the master that I can, means you can write to me. I am ready, like that. Okay, read from the target. Suppose master, this is for write operation. Suppose master want to read from the slave. Okay, so it will comes from the controller, okay, write means what? As ACK is coming from the target device, from the slave it is coming ACK. Okay, read means what? Master will send the ACK to the slave asking that can I read whatever the data present in you, can I read, like that it is asking. Okay, that is read from the target. Okay, so what happens, how we are giving the ACK means HDA will be pulled low, and it is pulled low during SCL is 0. SCL is 0. Okay, that is nothing but acknowledgement. Okay, and after that stop condition. Okay, so this is one more sixth. Okay, so in the programming, each and every one we need to check. Okay, there will be, we need to use FSM, and each and every steps we need to check based on this operation only. Seventh is stop condition. Stop condition. So what is stop condition? First, SCL. So I2C stop condition comes from the controller and sends SDA high before SCL sent high. Okay, so it will be SCL high before SDA sends high. Okay, this is stop condition. Okay, this is about I2C protocol. There are some questions are there. Suppose this is one question. Before address frame I2C communication, what action make up start condition? Okay. So what is the start condition? We already seen. First SDA will go from high to low, and again then sets SCL to low. Okay, this is the option. First this option, this operation from high to low. Okay, after that second operation SCL will go from high to low. This is not much start condition. And in address frame, after the controller device sends 7 bits of data, what is the next part? After 7 bits of data, what is that operation? If you observe this timing diagram, read by write bar signal. Whether master should read the data from the slave or slave should write the data into the slave. Okay. So controller device, whatever our master is there. Controller device means what? Master will send read by write bar bit indicates want to read from or write into the target device. Target device means slave. Okay. So this is one more. And because of NMOS open drain condition to HDA to SCL, which part of communication waveform is faster? Fall time is faster. Fall time is see here. This is fall time is faster, but it is taking some amount of time. No, rise time it is taking some amount of time. So fall time from HDA and SCL is faster. Okay, in the open drain condition. What is the benefit of having open drain connection over push pull? Okay, this will prevent destructive current draw during the bus contention. Output are tied together. Okay, so when you are using push pull, you are getting indeterminate output. You can't find out the output. Output can be don't core condition. Okay, so if you are going for push pull output, may pull a large current when output are tied together and there is a bus contention. Okay, this is about today's session.